Hi everyone. So it's between marks basically, so it's processing IoT sensor data, but as we will see later, you can basically process any data with it. But it's mostly for time series data, as we will see later. So my name is Johan Janssen. If you have any questions later, you can also tweet me or email me or whatever basically. Content of the next hour. Basically, we go through why would you do something like this, or why did I do something like this? How do you create a setup like this? And then how can you build something around it? And I will show some different examples based on Spring Boot. Any of you here using Spring for frameworks? Okay. And then I'll talk a bit about the challenges while setting up things like this. And we'll go to a conclusion. So first, is this a marketing page? No, I'm not involved with any of the tools that I'm currently presenting. I work for a company called InfoSport in the Netherlands, and we basically do consultancy and training for everyone who wants to do it. So for me, you can happily replace any of the parts that I show in this demo with alternatives. I'm perfectly fine with that. If you have any questions, you can easily interrupt me in between. I'm happy to answer them in between. You don't have to wait until the end. Just ask if you have any questions. If something is unclear or you haven't heard of it yet and want some more explanation about it. So now we'll come to the part of why. Why would you create a setup like this? For me, one of the first reasons is I like to try out new stuff, basically. I automated Lego trains with Raspberry Pis. I use all kinds of frameworks and tools related to Java development, Docker, anything basically. And I like to try out something new which is coming out to see if it is any help and if we can use it in projects for our customers. And I had one other good reason, at least I think it's a good reason. I have a garden which produces vegetables and fruits. And I try to increase the harvest, basically. Next to that, I have a basement. It looks like this when I'm dreaming. Otherwise, it's a bit emptier. And I want to control the humidity in there, because sometimes it's a bit humid in there. And you have tools like this, which is a dehumidifier, which you can basically turn on, and then it will dehumidify your room, basically. And for the harvest, I could use like weather stations like this. Or like this. But then I still have to do some manual work. I want to connect everything together and make sure that I increase my harvest and that my basement has the right level of humidity. So what do we want to measure? Not sandwiches today, but basically things like how light is it? Do we have sunny weather? Because that's better for our vegetables. Is it dry? Because then I need to give them water. Or is there a lot of water? Then maybe I have to try to get the water away. How is the soil? Is it good? Did I use the right fertilizers and stuff like that so that I can increase my harvest? And the difficult thing is that it depends also on which plants that I'm using. I mean, some plants, they require lots of water. Other plants, they don't want a lot of water or maybe no water at all. So for different places in my garden, I basically have to measure what's going on, and based on what's going on, I have to give more water or whatever, basically. So all kinds of places in my garden. It's not actually my garden. I have to take nice pictures in the summer after my garden is also nice. But probably by now you're like, okay, this is lots of talking about flowers and vegetables, and I'm done with it. So let's go to the more technical part, because that's probably where you're more interested in. So let's get started with that quickly. What did I use as a setup? I basically use a couple of things, just as a tryout, to try out different things. This is a sensor working with Bluetooth, and it measures the temperature and the humidity. This is a sensor which you can basically put in a pot or in your garden, and then it will measure all kinds of things like humidity. We will see the exact things in a moment. This also works through Bluetooth. This thing over here, it's a BME 280 sensor. It's connected to the GPIO pins of my Raspberry Pi. Anyone familiar with Raspberry Pi? Who owns a Raspberry Pi? Is it collecting dust on a shelf? Yeah, lots of them are. So this is maybe a reason to use it. So I use the Raspberry Pi with the GPIO ports, which I connect to a sensor, and then I can read the data as well. So this retrieves a set of data, this retrieves a set of data, and this retrieves a set of data. And there is a sensor inside the Raspberry Pi as well, which measures how hot the Raspberry Pi is getting, and I'm also reading those values. I often want, yes?
Does the blue sensor, does it have Bluetooth?
These two have Bluetooth.
Yeah.
What do you mean?
I mean the blue sensor next to the Raspberry Pi.
This thing? Oh no, sorry. This thing doesn't have Bluetooth. This one is working through the GPIO pin. So these cables make sure that the data is flowing from this sensor to the Raspberry Pi. It's going over these wires.
Right,
So no wireless connection there.
okay, so just another question. Why do you want to plug into the blue sensor?
So why would I want to plug in this one is the question?
Yeah.
Yeah. We will see that later. Good question. And often when I see things like this, I'm like, okay, it looks really cool, but probably it's really expensive. That's not really the case. I mean, lots of you already have a Raspberry Pi, and else you can buy it for a few bucks. And these sensors are like, I believe it was between 5 and 10 euros each. This one was a bit more expensive, like 20 euros. But I bought now almost the same sensor for like 2 euros. So you can get cheaper models as well. But be careful, they have like a really cheap model of this one for just a few cents, but that's only the chip. So it's really, really small, like 1 millimeter, and you cannot connect any wires to it. I made the same mistake. I wanted to bring it to show it, but I lost it. It's that small, really annoying. So don't buy that one. So for Raspberry Pis, Raspberry Pi basically is a really small computer. They exist for a couple of years now, and they have all kinds of models. And I think these are the most interesting models that are for sale now. So they have the 3B Plus model, which is a quad-core computer with a lot of memory in it, and with all kinds of networks on board, like wireless, normal connected LAN, and Bluetooth. The 3A Plus is more or less the same, but then a bit limited, like memory is a bit less, and they have a bit less connections to it. And the 0W, that's a 1 gigahertz single-core CPU with a bit less memory than this one and a bit less connections. So which one would you pick? Basically, it depends a bit on what features that you want. So do you need the wireless? Do you need the amount of memory? How much money you have, because the 3B Plus is more expensive than the 3A Plus, and the 3A Plus is more expensive than the 0W. And power consumption, because there's quite a big difference between the power consumptions of those three. I found some data on the internet which I put in this graph. So here you can see that for the 0W, it consumes about a quarter of the power of a 3B Plus. So if you don't need the power, then I would suggest using like a 0W. Especially if it's laying in the garden or somewhere without a power connection, you could use a USB battery pack to power the Raspberry Pi Zero, and it could run for like a day or something like that, depending on how big your battery pack is, of course. Okay, so how is it set up? Basically, I connect everything to my Raspberry Pi. So these two connect through Bluetooth. This one connects to the wires to the GPIO pins of the Raspberry Pi. And I run Spring, which is a Java framework to build enterprise applications. So it's not specific for Raspberry Pi or for sensors or anything. We use it to build large applications for financial institutions in the Netherlands. So it's a generic framework, basically, which is used quite a lot. And it has some nice features which make it easy for me to build this application. For the sensors, so I have the GPIO sensor. This is the BME 280. And I have two sensors from Xiaomi. Xiaomi is a Chinese manufacturer that sells lots of equipment, lots of sensors. And some of the sensors you can read through Bluetooth. and some sensors you need to have a gateway. So they say you always need to use the gateway to connect all the sensors to the gateway, and then you connect your laptop to the gateway. But for these two, you don't actually need a gateway. And I didn't want to use a gateway because it's connected to the internet, and I don't need China to read all my temperature data from my flowers. Raspberry Pi, it has an internal sensor, so it's in the Raspberry Pi itself. You cannot really see it with your eye. So what do they measure? This is basically what they measure per sensor. So you see that there is quite a difference in the things that I can measure. For the Bluetooth ones, I can also measure the battery level so that I know when I need to replace the battery before it runs out. One thing that's quite interesting to think about is where do you run your application, where do you build your application? It's a Java application which I built. And normally you see more like C and Python applications on a Raspberry Pi because they are less restricted on resources. Java is a bit heavier. So if you want to build it on your Raspberry Pi, it takes a bit of time. So what I do is I build the application on my laptop, and then I basically transfer it to the Raspberry Pi and only run it on the Raspberry Pi to save a bit of time. But if you have enough time, and especially with a quad core, you could also do this on the Raspberry Pi itself. So to go a bit further into the setup, so I use Spring to read out all the sensor data, and then I use Spring to send the data to InfluxDB, which I'll cover in a minute what InfluxDB is exactly. And then I show it in a dashboard like Chronograf or Grafana. There are all kinds of dashboards which you can connect to InfluxDB to show the data in a nice way instead of just numbers in a big database. To start InfluxDB and to start the dashboards, I use Docker Compose. Docker, how many of you have heard of Docker? Yeah, quite a few. Nice. So it looks a bit like a virtual machine. It's basically containing an application, but it's much better than a virtual machine. So I can highly recommend to look into that. It's really popular and everybody needs to use it nowadays, at least it seems so. So I use Docker to quickly start up the applications that I'm using, and then I'm good to go. So I run Docker Compose on my Raspberry Pi in this case. So InfluxDB and my dashboards run on the Pi itself. It's powerful enough for that. I could also opt to run those on my laptop or on a server or whatever. If I would have multiple Raspberry Pis with sensors around my home, it would make more sense to run the database and the dashboard on a central server or something like that. InfluxDB. Any of you have heard of InfluxDB before reading my session abstract? Ah, cool. I see a few hands. So InfluxDB is an example of a time series database which can be used to store data, like any database. And for databases, you could use like the traditional approach. I could store the data that I have from my sensors in a MySQL database, in a SQL Server database, in an Oracle database. It doesn't matter. They support it as well. But it's a bit like this picture. I mean, you can use a hammer to fix anything, but sometimes it's better to use tools for the right job, or the right tools for the right job. So that's why I opted to try out a time series database, and I came across InfluxDB. It looked quite nice, so I started using that one. But there are some alternative time series databases. Some cloud vendors even offer you a cloud-hosted time series database. So how does InfluxDB then works? We can start basically a Docker container. I can show it to you live, that's maybe nicer. So here is the example. I use Docker Compose to start up like InfluxDB, Chronograf and Grafana. So all the dashboards are started automatically if I start Docker Compose. I already started Docker Compose, so this stuff is already running in the background. And what I can do now, let's see where we have that one over here. I can connect to the InfluxDB Docker container that's already running, and I can connect to it, and then it will start a command line interface. And basically it's like a command prompt for InfluxDB. So I can issue commands to InfluxDB. So I can say, for instance, show databases, and then it will show the different databases that I have. So I have basically 3 databases, one to store data that I send through a REST endpoint, one with a Java client, and one where I use a Spring template to store the data. But I'll show you later how we do that. Let's first have a look at how basically InfluxDB stores the data. So I can say which database I want to use. For instance, the Java client sensor data. And then I can say show measurements. Is it readable from the back, by the way? Is it large enough, the font? Okay. And so now I can see the measurements that I'm doing. So I, for instance, have measured. Oh, it's. Now it's better. So I measure, for instance, the ambient humidity, pressure, temperature, battery level. And you see I had 2 sensors which both had a battery level, both the Bluetooth sensors, and they store it in basically one measurement, the battery level measurement. So if I say select, let's make this a bit smaller, then you can still see that as well. Select star from battery level. So now I see the battery levels for both my hygrothermograph sensor data and my Flora sensor data. So both measure the same thing, so I store them in the same measurement. And so I have a whole bunch of measurements which I can basically query. I can do counts on it like you would do in a normal SQL query. All kinds of information available here. So let's see. I think we've covered the first parts here. Yeah, I could even do something like this. Not that one. This one. Oh, it's already gone. Let's show it here. So I can do things like group by, so that it's grouped by the sensor that I have. And then the result, there's quite a lot of data now, but let's see if I can get to the top. So I group by sensor. So first it will show me the results for the BME 280 sensor, and then after a while it shows it for the other sensors as well. So things like group by, count, and things like that, which you might be used from SQL, standard SQL queries, can be used here as well. One thing which I don't know why they did it, but this thing is a timestamp. I don't know for you, but for me it's quite hard to read. Luckily we can set precision to some thing, and then we do a select again, and we get something which is a bit more readable. So if you want to query the data, this is a good way to format the data in a readable way. Except for measurements, they also have the notion of series. And series basically show what kinds of measures I have available. So I have the ambient humidity measurements for the BME 280 sensor data, and I have the ambient humidity measurements for the hygrothermograph sensor data. So this basically is like matching all the different measurements that I have against the different sensors that I have available. In the same way, I can also store my data, so I can simply say insert into ambient temperature things with host is this number, this IP address, and the sensor is this value, and the value is 21. So this is a way to basically insert values manually into InfluxDB. But I'm not really interested in doing this manually. I'm a Java developer, so I wanted to do this with Java, of course, and some coffee. Based on Spring Boot. So we're going to look at 3 different possibilities to use Spring Boot to send the data to InfluxDB. So one is REST. So basically we do REST calls like you would do to REST endpoints basically. InfluxDB has a REST endpoint where I can send data to. So the nice thing is, the REST endpoint of InfluxDB, it's a general REST endpoint. So if you're using Python or any other language, and you can do REST calls, then you can send data to InfluxDB. So it's a really general purpose solution. The InfluxDB Java is a library specifically for Java to store data into InfluxDB. And the Spring Data InfluxDB project is basically a layer on top of that to make it even easier to store data in InfluxDB. So we'll start with the way of using the InfluxDB client from Java. And to do that, we first do some configuration. So we connect to InfluxDB. So InfluxDB is running on the same machine on port 8086 with these credentials, super secure of course. Then we create a query basically to create the database where we want to store our data. And then we have to set the database which we want to use. And this is basically to configure, and then we're ready to go. Of course, this is in code in just one slide. You could make this a bit nicer and put this in configuration files. For instance, if you use Spring, you could wrap it in a bean and specify properties like this so that you can easily configure it without having to change your Java code. So that was basically what we needed to set up everything. Now we're going to see how we can actually send data to the database. And to do that, we use the notion of points. So a point is basically one measurement. So for a sensor, for instance, I could read the sensor data every 10 seconds. So every 10 seconds, I would have another point of measurement. And in that point, I specify some things. I specify the name of the measurement, in this case, the ambient temperature. I supply it with the current time in milliseconds, because it's a time series database. Everything is stored based on time. And then I'm going to add tags to it, a host for the host IP address. This is the IP address of my Raspberry Pi, sensor for the name of my sensor. And this is of course a variable that I retrieve from somewhere else. And I add a field, and the field in this case is the value, so the temperature, which was 21 in the previous example. Maybe you notice that I use both tags and fields to store data in a point. And the reason is that field and tags have a big difference. Fields are not indexed and tags are indexed. So if you know about regular SQL databases, if you query on certain columns often, you want to index them because then searching is quicker. The same goes for this time series database. If you want to query on something, then make sure that that field is indexed. So make the field a tag and it is indexed. Then storing it is actually quite easy. There are some methods available like write the point, or you could even specify things like retention policy, how long did you want the data to be kept in the database before it's automatically removed. So this is the basic setup to write stuff. You could also do batch sending of points. The big advantage of that is if you do lots of measurements, like every few milliseconds, and you're sending those directly to InfluxDB, then of course you have a lot of network calls, which can slow down the performance of your application. And then it's better to use batch and basically bundle a set of points and send them to the database 100 at a time or 1,000 at a time, whatever you want. And so this is a complete setup to use InfluxDB with the Java client. This is completely working. But as I mentioned, there is a layer on top of it made by Spring Data InfluxDB, and it makes it a bit easier to work with. So you could also use this solution if you use a Spring project. To do that, we have in Spring a so-called application.properties, where we specify a lot of values. And there we can specify basically how we connect to our InfluxDB database. And then in the code, it's really easy. We can say that we want to have an InfluxDB template with a specific point, and that it should be auto-wired by Spring, and Spring automatically makes sure that we have this available. And then we can use the same methods again. We use the same point as we've seen before, so the point doesn't really change, and we again use write to write the points to the database. So there's not much difference except that it's a little bit nicer code to write. If we go for the REST example, we can specify the REST URL. We specify the measurement. You see this is a bit ugly with all the string concatenations that I'm doing. And then I can say, okay, REST template, which is a class within Spring to do REST calls to an endpoint. I want to post the data to this URL, so the URL here, and I want to send this measurement. And then it will also be stored inside the database. I would recommend that if you can use Spring or the other InfluxDB Java client, use that because it programs a lot easier and a lot nicer than this with using string concatenations. But if for whatever reason you cannot use them or you have a programming language that doesn't have a client library for InfluxDB, then you could use the REST endpoint. So it's more like a backup for me. I wouldn't use it as the primary means. We can also get the data back from InfluxDB. You can also do that through the REST endpoint, but I show you an example where I use the client. So I can define a query where I select the ambient temperature and group it by host and sensor. And then I can say, okay, query it and return the result. If I do that, it looks a bit like this. So this is a part of the result, with all kinds of arrays inside arrays, which is a bit difficult to read, and it's also a bit difficult to use. Because if I would write a unit test for this, I would have to get the result x, in this case result 0, and then in the series I have to get again some index value, and then I can assert that that specific field has the correct name and has the correct value inside it, and that things like the temperature are okay. But you see there's lots of getting on all kinds of indexes, which is quite annoying because if it changes a bit, then you have to basically change all those values as well. It's not really maintainable. So I don't really like to work with all those numbers. Luckily, we can, if we read or if we execute a query, we can convert the result into a Java object immediately. So this is a Java object, a Java class ambient temperature. I put some annotations on top of it, so I say that it's a measurement and that I store the ambient temperature inside it. And then for every field, I basically make a variable and then annotate it with the right annotation. So at column host, and I say it's a tag, so it's not a field but a tag. The same goes for the sensor. And the value, it's simply a value, it's not a tag, so I don't have to specify anything there. Then I need to write a little bit more code, but that's basically copy-pasting. So I again have the query result, but then I make a result mapper, and in the result mapper I say that, okay, the result of my query, I want to map it to the ambient temperature class, which is shown here. So that way my result is automatically converted in a nice object, and I can use that object to test against. So I still have to, I get a list of results back, a list of measurements. So of course I first have to get the right measurement, so I still have one get from the array. But then what I get back is an ambient temperature object. And in the ambient temperature object I can use the simple get methods to retrieve everything I want to retrieve and assert that the right value came back. So this is a nice way of dealing with results of data. Actually, for my solution, I don't do anything with the results. I only show them in a dashboard. So it depends a bit on your use case if you need those results. If you want to do something programmatically on it, if you want to use them in Java or in your language, then you will need this. But if you use a dashboard, then you can simply use the dashboard to display the values and not worry about the results. So a dashboard looks a bit like this, or in our case more like this one. Let's show that live as well. So this is Chronograf dashboard. Chronograf is from the same vendor as InfluxDB. It's both for free, you can use it for free, but it has a nice integration. You can also use Grafana, which is a more popular dashboard solution, to display the same results. It doesn't really matter, but my experience is that with Grafana it's a bit harder to set it up. Just takes a bit more time, but luckily you don't have to change it every day, so it doesn't matter too much. So I have a dashboard here. So I'm receiving the values live. So let's see if it's automatically refreshed, I guess. So let's see if I can make a sensor go up. And let's see. I think I should add a graph. So that's a nice way to show how you can add a graph for it as well. So I'm going to make a graph for the BME 280, which is the one connected with the wires to the Raspberry Pi. And I want to show the temperature. So this is the name of the graph which I'm going to make, and then I'm going to select it. As I've explained earlier, I can select it basically from 3 different databases. One which is used to store the REST data, one for the Java client data, and one for the Spring template data. So we'll pick the Java client sensor data, and then we'll say ambient temperature. And I only want the temperature for the BME 280 now, but I could also say that I wanted to see it for all. So let's simply do all, and we call this, we'll start with 1, BME 280. We want to see the fields, the values. And let's see if I submit this and say OK, then I get it over here. So now I have a graph. I didn't code anything. I selected some values and I'm good to go. If I now put my finger on the sensor, and make sure that it's actually refreshed. Now the temperature goes down. That's not completely what I mentioned. It's refreshing basically the data every 30 seconds. So every 30 seconds, I measure all the sensors and send the data to InfluxDB. I can, of course, configure it to do that every 5 seconds. But for me, every 30 seconds is good enough. So now we see a spike here because I put my finger on the sensor and then the temperature goes up. So I have more or less live data here. I can configure here whatever I want. So I could also adjust the query. So this query is automatically generated while clicking through it. But I can adjust it if I have a more complicated query as well. So I can also say, okay, I want all the 3 sensors inside. And then I call it the temperature. I can even choose a different visualization. Basically, whatever you want, it's all possible. Let's see why it didn't display everything now. I would have expected 3 values now, but apparently the other 2 aren't loaded at this point in time. Exactly, thank you. So indeed I have to group it by sensor so that the data is separated. And I can again do that simply through the interface, or I could have added it here into the query. And then I can say, okay, save it. And I'll have a nice graph here. And everything is customizable, so I can basically change here whatever I want. I can say I only want to have like the last 5 minutes of data, last 15 minutes. So it's really flexible. You can do with it whatever you want. And so I only had to do some programming to get the data inside InfluxDB. All the rest was basically just clicking through some interfaces, and I had a nice overview of what's going on. And the nice thing is, I not only can see what sensor data is being retrieved, so what temperature it is at this point in time, but I also measure the duration, how long it takes to read the sensor data. So if I read something through Bluetooth, it takes quite a bit of time. If I read it directly on the Raspberry Pi, it's quicker. And for every measurement, I also store the duration and store it in the same graph. So that way, I can see which sensor is quick and which sensor is slow. So that's an example of data that I could use that for IoT stuff, but I could also use it in my enterprise application. If you do queries to a database, you could measure the duration of every query, and you could then store it into InfluxDB and make a nice graph about which queries take a long time and which queries are really quick. So you can use it for more things than just IoT sensor data. Yeah, one thing you shouldn't forget is make sure in the dashboard at the top there is like a refresh button, and by default it's disabled, so it's not refreshing. So you might think, hey, where's my data? It's not working. And then after a while say, hey, what does this button do? And then it works. Okay, so was this all easy to do? Some things were a bit more difficult or annoying or surprising. For instance, to read some of the stuff with the GPIO pins, so the blue sensor, I used Py4j. It's a Java library to read GPIO stuff. And then I was, okay, new version of Java came out, Java 11, I want to use a new version, tried to get it running, didn't work. And then I looked at the project and it didn't have any new commit or release in like 1.5 years, and the owner wasn't responding to any questions anymore. So it was a bit annoying. I couldn't use a new Java version, and there wasn't really a great alternative for it. I have to say later, surprisingly, the owner responded, and he's now actively contributing again, and there are some other contributors on board now, so the project is going on better now, but it's a bit of a challenge if you want to do things quickly and want to use new technology. And yeah, some projects are abandoned. Maybe you can still get them working with Java, but often it's with IoT stuff, it's more getting your hands dirty and use some other stuff than Java. For instance, Python libraries or C libraries or simply Linux command line tools. For Bluetooth, for instance, I use a Linux command line tool which can connect to a Bluetooth device, send some commands to it, retrieve the result. I could maybe do the same with a Java library, but the ones that I tried didn't really give me nice results or weren't updated for a long time. So I opted to do that by hand. And actually in Java you can do that quite easily. I can say execute from a command, and this is just a command. If you're used to Linux, I can do like ls to do a directory listing, or I can start an application or whatever. I can supply any command that I want, and it will be executed as if you're typing it on the command prompt or in a shell. I can then retrieve the result by using the process input stream. So here I get a process, and I retrieve the input stream from the process, put it in a scanner, and then I can read the result. So I can read, for instance, the temperature that's being returned by the sensor. I can also retrieve errors if something went wrong with the sensor, if it couldn't retrieve stuff. So then I was, okay, now I have a nice solution. I have an error fallback. I read my sensor data, but for whatever reason, it wasn't the finish. After like half an hour, my application would stop. So I made a really basic application. It would output all the sensor data on my shell. So I didn't even send it to InfluxDB. I just printed it so that I could see if my sensors were being read correctly. But after like half an hour, every time it crashed. And after a while, I found out that apparently the process kept on running endlessly, so it wouldn't continue anymore. And luckily there was another bit of a hack for it to basically say, okay, if the process takes longer than 20 seconds, basically destroy it and then continue, which is a bit annoying. And so I had to do a few hacks to make sure that I got the right results. And these are some of the results. So this is the temperature measured by 3 different sensors. 3, yes. Can anyone say what's strange about this? The sensors were, by the way, laying next to each other just like they are laying now. Nothing strange here? If I measure the temperature now, it's like 20 degrees. I would say, I can say actually. 25. It's a bit warm, but probably it's because it's laying quite close to my Raspberry Pi. So put it a bit further away. But the fact here is I have 3 sensors laying next to each other. All 3 giving a different result for the temperature. So who's lying? I don't know. So if you use different sensors in different rooms, I would really make sure that they have the same calibration, or use the same sensor that basically has the same calibration, because else you get quite strange results. If I would use like a Bluetooth sensor in my living room, and in my bedroom I would use like the GPIO sensor, and I want to maintain the same temperature, then it's quite difficult if they return different results. Next to that, I also had some exceptions. So I don't only log the time duration, so the time it takes to retrieve a measurement from a sensor. I also log it if there is an exception retrieving a value from a sensor. So if a sensor takes too long or whatever, it is logged as an exception, and it's also sent to the InfluxDB database. So in the time series database, I also store at which point in time I had an exception and for which sensor. Basically, it came through to this. So we see here that especially the hygrothermal graph, and for the ones that didn't remember which one it was, which I can purely understand with such a difficult name, is this one, which had quite a high error rate. The Flora sensor had a few errors, both were connected to Bluetooth. The other ones were basically faultless, they worked pretty nice. So now I got the question earlier, why would I use a BME 280 sensor, the blue sensor? Yeah, it's performing way better. I have way less exceptions in it. And it's basically through Bluetooth, at least that's what I found out. And maybe so I'm doing a bit hacky with the Bluetooth connection. It isn't officially supported by the vendor. So maybe if you have like a proper Bluetooth device, then it might be more stable than the solution that I have now. But of course, wireless always has a bit of an overhead, and Bluetooth as well. And the other thing that came to mind is the response times of the different sensors. So these are the response times of the different sensors. I only see two sensors basically here. That's because the other response times are so low you cannot even see them. So if I simply do a measurement and do a query, so all the queries that you're seeing I did on the InfluxDB database. So it looks quite like SQL queries that you might have been using before. And then we can look at the response times in numbers. And now you can see how big the difference is between like Bluetooth, GPIO, or directly within the Raspberry Pi. So it's huge. So some are slow, some are really quick. Which one should you pick? For me, it didn't really matter. I'm fine if I have a measurement every 30 seconds. I don't need measurements every second because my temperature isn't fluctuating that hard. But if you want to have real-time measures, for whatever reason, because temperature is so important for you, then yeah, you could probably use better use a GPIO sensor. Same goes for exceptions. I mean, I don't care that now and then one of my values is incorrect. I simply ignore that value, and 30 seconds later I have another value. And I don't know, maybe 1 in every 100 measurements fails. I'm perfectly fine with that. For my use case, it's not an issue. So basically, this is good enough for me. But it depends a bit, again, on what you want. So to come to the conclusion, for me, InfluxDB, I never worked with it, but with a bit of Googling and looking at the documentation they provide themselves, it's quite easy to set up and start working with. It's also quite easy to store your data in it. And making dashboards is probably even easier. And if you want to have a look at it, I can also show some code because I think we have more than enough time left. I put the application on the internet as well. Let's see, where is it? I first have to close this one. So in GitHub is the entire project, including the Docker setup and everything. And it's not really that difficult. So this is basically only introduction. You need to set up an SD card and configure the Wi-Fi, enable a few things for the sensors, and then I created a script which basically installs all the necessary software. So you execute the script, you can start up the Docker containers, create the Java application and start it, and then you're up and running. So this is basically all the steps that you need to do to get to the same result. And how does it look like in code? So I've shown some small examples, but I can show a bit more how it works. So for instance, if I look at the Raspberry Pi sensor data, which is the CPU temperature, so the sensor inside my Raspberry Pi, and I want to send it with a REST call to InfluxDB database. So basically what I do is I make a string measurement. The measurement is the CPU temperature. I specify the host IP address, the IP address of my Raspberry Pi. I specify what the sensor is. In this case, it's the Raspberry Pi internal sensor, and the value. And then I can use the REST template from Spring to post it to a location. And then I'm done. So that's basically all I need to do. And I could do the same with the InfluxDB template. So this is the Spring-based template that I can use. And then I basically say, okay, I want to create a database with the InfluxDB template. Then I create the points. So these are the points I've shown before with the tags and the fields. And then I can simply say, okay, make sure that the list of points is stored with InfluxDB template, and it's automatically stored inside InfluxDB. This is not the one I wanted to show you. The same goes for the duration. So how long it takes to retrieve a certain value from a sensor. So I start a duration, so I take the current time, I execute the measurement, and then after the measurement is finished, I measure how long it took, and that I store in a point as well, and that point is being saved in the database as well. So it works the same way as storing IoT sensor data. Same goes for exceptions. So if I retrieve an exception, I put it in what I call exception point, and then I store it inside the database, all in the same way. And this is the example on how you execute Linux command basically from within Java. So with runtime get, runtime exec command, I can basically execute any command I want. And you see here that I automatically destroy it after 20 seconds if I don't get an answer back before that. And else I do error processing or simply process the data that's being returned. And for like sensors, they often need some kind of a bit of calibration. For instance, for the BME 280, the blue one here, it's being calibrated by this piece of code. I didn't invent it myself, it's the better stealing. There are lots of libraries and stuff available who already did this for you, so unless you really want to do this yourself, I would advise you to take one of the examples that are already out there on the internet. So basically all the configuration, everything you've seen is in this application. It's the same application that's running on my Raspberry Pi. And you can find it on the internet, so on my GitHub account, which is shown above, if you're interested in seeing more about it. Yeah, one note about the example application. I know there are some bad practices in it, like duplicated code and stuff like that. But I think it makes it easier to understand if you look at it for the first time. So don't blame me, I did it on purpose. Any questions? Then thank you all.